Algebra 2 Regents, sample video number 5. What is the completely factored form of this mess? K to the fourth minus 4k squared plus 8k cubed minus 32k plus 12k squared minus 48. Um, you know, uh, this is a pretty hard thing to factor. This is the most complex factoring I've ever seen in an Algebra 2 course. We've of course factored trinomials and binomials, and we've seen what we call AC factoring and grouping and all sorts of stuff. We've never factored anything this huge before. And that's the kind of stuff you're probably going to see on this Regents is some pretty advanced factoring. And the key here is recognizing structure. You want to try to factor it like you factored other things. And I know that sounds weird because you've never done anything like this. But first thing we always look for is, GCF. See a lot of K's, but this doesn't have a K, so I can't take out a greatest common factor. So rule that out right there. My highest exponent is 4, so I'm probably going to have 4 factoring. Now, one other thing you could do is, well, I guess before I start talking about other, I'm going to show you 2 other ways to solve this question besides the way that they want you to. But is I would think about grouping. First thing that might comes to mind is, all right, maybe I can just do a trinomial here and a trinomial here, but that actually doesn't work because this is not going to be good and it's a little out of order. And so the way you're actually supposed to factor this is by factoring by grouping. Now, what we've had in the past is if I blank this out for a second. Remember when there's 4 terms, what we do is we draw a line and factor it, 2 terms here, 2 terms here. Well, that's exactly what we need to do, except we need to do that with 3 groups instead of 2 groups. That here, now I see that there's 2 here, 2 here, 2 here, and there's something in common with each group. That's the key, is if you can split it into groups that there's a GCF per group, that's a good way to go about it. So here, I can factor out a k squared, and I'm left with k squared minus 4. Out of the 8 and the negative 32, I have in common 8, because 8 times 4 is 32. But we could also take out a k here, because they both have k, and we could take out k. What's left over would be k squared minus 4. And right there, you say, oh, wait a minute, I got k squared minus 4 and k squared minus 4. So this grouping method only really works is if, when you take the GCF out of each group, you're left with what's called the common quotient. Kind of looks like a 9, but it's a 4. And over here, again, I could take out something in common as a 12, but no k's. And I'm left with k squared minus 4. So that's telling us right there that we're on the right track, because both quotients, what's the result of the factoring is called the quotient, or result of division, is k squared minus 4. So that is one of my factors, because what I basically do now is I take k squared minus 4 away from everything, and what's left is when I take k squared minus 4 over here, I'm left with k squared. When I take it from here, I'm left with an 8k, and when I take it from here, I'm left with 12. And now we're down to normal factoring that you're used to. This is a difference of 2 squares, so k plus 2, k minus 2. And here's a very standard trinomial. It multiplies to 12, adds to 8, and that's k plus 6 and k plus 2. And I'm just noticing that k plus 2 is repeated twice, but I think that's fine. So we're looking for plus 2 minus 2, plus 2 minus 2, 6 and 2, and here's our answer. The results, if we were to solve for k, we would have negative 2 with a multiplicity of 2, because there's 2 factors of k plus 2. And we would also have a positive 2, multiplicity 1, and a negative 6. Right? Positive 2 from this and a negative 6 from that. So I mentioned that there is another way to solve this question. That you should know how to do. It's definitely the grouping, especially 4 terms. 6 terms, like I said, we've never seen this before in Algebra 2 until this question. So this is kind of new. But like I said, it's an extension of what you should know, and that's what a lot of Common Core is. Apply what you know in kind of a different way. Do you recognize that you can use grouping? So you look for GCF, so you look for grouping to work, things like that. But because it's multiple choice, a lot of times we could go backwards, and what I mean by that is we could guess and check. We could take this term and distribute it. If you multiply these two together, you'll get k squared minus 4. If you multiply these two together, you'll get this. And then if you distribute this out, k squared times each of these and negative 4 times each of these, distribute it out, you'll get this. So, you could guess and check, work backwards anytime it's a multiple choice factoring question. But that's a tremendous amount of work. And of course, the last answer is the one that works. It's going to take you a long, long time. One other option is the calculator option. What we can do is we could type in this ridiculous equation in our y equals. If we type in x to the, we're going to have to use x instead of k's, it's okay, x to the fourth minus 4x squared plus 8x cubed minus 32x plus 12x squared minus 48. And I'm just going to check this 1, 2, 3, 4, 5, 6 terms. And then let's take a look at Zoom 6, our standard graph, and see what happens here. I see there's one time it's crossing, it's bouncing there, and it's crossing somewhere else. And this graph should make sense based on what we know about graph structure. Here is your negative 6 multiplicity 1. So if I know a solution is x minus 6, that means I know a factor is x plus 6. A solution is x equals negative 6. It's a little sloppy. Let me rewrite that. X equals negative 6. So that's why the factor is plus 6. Here we have a positive 2. X equals 2, which means we're going to have x minus 2, or k minus 2. And then here we see the negative 2. X equals negative 2. But the fact that it's bouncing means that it has an even multiplicity, which could be 2, 4, 6, 8. But based on the fact that we said that it's degree 4, means it has to be multiplicity 2, because that's 1, 2, 3, 4, which gives us our degree 4. So you could kind of find the roots from the graph and then turn those roots into factors. Like if I had x equals 7, my factor would be x minus 7. Kind of working backwards. And the graph's not, it's kind of hard to tell from the graph, so I could always take a look at my table. And I see that at, this is a little small on your screen, but you see that at negative 6, I have a y value of 0. At negative 2, I have a y value of 0. At positive 2, I have a y value of 0. Y value of 0 is your x-intercept. Those are your roots. So, like I said, you could get the roots and turn them into factors. You can guess and check, or you can do the factoring method, which they want. Now, of course, if this is a part 2 or 3, then you can't guess and check, because there's not choices. So then you're down limited to this or the calculator type of thing. And even using this calculator method, it might give you the right answers, but it might not give you full credit, because if it's a part 2 or a 3, they're going to want to see the work for partial credit. So it's a tough question. Factoring is something that a lot of students struggle with. You really have to be great at factoring the basic methods. Like this, you should be able to do no problem. This, you should be able to do no problem at all. And if you're having issues there, then you really need to strengthen that somehow. But then when you get something that's weird looking, you've never factored that before, look for the GCF, look for grouping maybe to work out, and worst case, try it in your calculator and experiment. All right, that's it for sample number 5. See ya.